I am sitting here today with my friend Renee Smith.
Yay. Thank you for remembering my name.
Come here. You got one of those little hanger things?
Oh.
There you go. It's gone.
Oh man, I used that to hang him up.
Oh,
but
sorry.
That's okay. I got another one.
Sorry. Renee just came in from working with the school district today, as she does, and she's fired up because she's getting ready to go talk to middle school teachers tomorrow.
No, next week, but
Next
close
week,
enough.
whatever. And she's here to correct me. And Renee works with folks about helping them to do better math, to learn math,
I do look
not just
silly.
algorithms. You do. You look like
I look
a
silly
Stevie
with
Wonder
my
there.
dark glasses. Okay.
You look good now.
Okay.
It's the end of the day. It's before school starts. We're cool with that. So I want to hear from you because you brought over. Where's your piece of paper?
I didn't bring it back.
Go get it.
Oh.
It's just right over there, right? Okay, so what she did is she came up to me and she says, hey, working with middle school teachers, she works with this process called CGI, which is cognitively guided instruction. Okay, in math. And really, I look at it and I'm like, holy crap, this is just PBL. This is PBL in math, and it's really set up for young students, but can go up quite a bit. To me, if you're wanting your math teachers to move toward project-based learning, toward learning by doing in math.
And thinking.
And understanding math, not just algorithms, because people like me who are dyslexic, we don't do well with formulas.
And procedures. You don't like those so much?
Me and procedures?
Yeah, that's right. Okay.
So she has come up to me and she said, hey, look what I'm going to do. And I'm going to be quiet and I'm going to let you, Renee, share with them what you're going to be doing with these teachers.
Well, so I end up with elementary people doing whole number stuff and fraction stuff. But then there's this misconception that when we get to middle school, okay, now they're really smart.
Right. They understand
and they
the
understand
foundations.
all the math.
Right.
Which
and if they didn't, they're supposed to anyway.
Right.
We shove them into it.
Right. And I taught middle school, and I know that's not true of all children. It's true for some, but it's not true of all. Mm-hmm. And so we think that then we can go straight to the abstract, which when we're pre-algebra and algebra are equations with, the study of the last three letters of the alphabet. X, Y, and Z, So I decided, okay, let's prove a point. And so I picked 5 algebraic problems that terrify the masses, things about scooters traveling in...
Oh, no.
Oh, you're going to read
right
it?
now. I'm just right now.
Okay,
I'd show it to you, but it's always backward here, so
yes.
Totally have to read this to you because Ginger, read this. She says, 2 scooters travel from the same point in the same direction, leaving at the same time. The faster scooter travels at twice the speed of the slower scooter. You know where we're going with this, right? Right. After 3 seconds, the faster scooter's traveled 6 feet more than the slower scooter. What's the speed of each? I'm already lost. I have to draw a picture.
Well, and that's the whole point of the exercise, is that they have children sitting in front of them every year that if they're allowed to use a tool or draw a picture, they'll be able to solve this problem. I mean, give me 2 number lines and I can draw this lickety-split.
But see, that's not real math.
Oh, okay.
Fight me on it and tell me where I'm wrong.
Well, it is real math. It's understanding at the conceptual level. I understand the concept. I don't know your silly equation. I don't know how to use an X in here. I just can solve and get the right answer. Mm-hmm. And I can tell you how fast the slow scooter and the fast scooter are going. But that's where I say we have a twofold obligation in math. Our standards ask us to help kids model, and
right.
One of those models is the algorithm or the equation.
Right.
And so I think we just need to reverse the operation. We used to teach them a procedure and then try to make them do word problems.
Right.
And everybody was like, oh, I'm not even going to assign those because they're too hard.
Oh, this is me and word problems. I do all the ones that were exactly like what they showed me on the board. We get to the word problems and I leave them freaking blank. And I miss the points and I don't care.
Exactly.
Yeah.
Exactly. And honestly, I'll be honest, there were times I would just look at them and go, okay, I'm not even going to assign those because there's no way they can do those.
Well, and we know in the real world, that's
how
what math is.
That's how it is. I mean, actually in real world, no, I wouldn't be giving you all this information. I mean, in PBL, in real life,
that's right.
I have a problem to solve, and now I got to go figure out what I need to know, and
right.
I've got to figure out how to solve it.
Right.
But, okay, so you have the information. Let them solve it in any way they can solve it. And then come back and say, okay, now, what did we know? What did we not know? Because that's our unknown. That's the X and the Y and the Z. And then help them see how to model the equation from their work. So I just kind of think we need to flip math over on its head and let kids figure out concepts and get deep into the concepts before they get to the abstract. And
I hear you.
Let me give a perfect example that just happened when I walked back into the office. One of our office workers said, I could have used you yesterday. I said, what for? And she said, well, I was trying to do long division, and all of a sudden the steps weren't, I didn't remember all the steps. So I grabbed a calculator. And I said, well, first of all, you're right on target for Common Core because you used a tool appropriately in a situation where you needed it.
Okay.
Okay? But the point of the matter is, she learned those steps a long time ago.
She did.
And because she hasn't practiced them
Learned
regularly, right, she couldn't come up with another way. We want our kids to be flexible. We want them to know lots of ways to solve.
Yes, absolutely. Okay, so I'm going to push back here.
Okay.
Because I think you're full of crap.
Yeah.
I don't think you are.
I know.
I'm just saying that. I want to be the voice. By the way, anybody jump in here and, you know, she's, the folks who follow me and we're friends, they're kind of already amongst those who've been believers for a while, but some of our colleagues aren't. So, all right. You got these kids doing all this discovery math.
Right.
First of all, how do I make sure that everybody does learn what they're supposed to learn at the same time? And how do I know that they're not just screwing around?
Well, okay, there's a fallacy there. We don't learn at the same time. We don't process at the same speed, and we don't all get there at the same point in time.
Oh.
Okay, that's the first fallacy.
I thought the ones who did earlier were smarter, and the ones who didn't were just stupid. We just labeled each other that way. Yes.
Well, and that's. Okay, I won't even say
it's
what that is.
Okay.
That's not okay.
This is just a bunch of crap.
Yeah, it is.
In the most
I'm gonna
nice
let
way
you
I
say
can
that.
say. Oh, I could say a lot worse.
but I, you know, in every training I do, I talk about that.
Right.
And that's why I believe in individual think time, where kids can actually process at their own pace, and then eventually, when it's time or enough people, I've talked with enough people, then we come back and we share. Because quite honestly, teachers know too much. Mm-hmm. Teachers at every grade level know too much. And I say it to primary teachers, I say it to middle school teachers. You guys are too good at the math. I can't erase from your mind the stuff you already know.
The curse of knowledge.
Right, the curse of knowledge. And so I have to make you do things like kids can do them so that you can experience them, because none of us experience math this way. We didn't learn it with manipulatives. Almost every time I do a training, I ask teachers, how many of you used manipulatives growing up?
I did, and then I got my hand smacked because only dumb people use manipulatives.
Well, and how many of you got to count on your fingers?
I did. I faked it out. I moved my fingers to where only I could feel them.
Right.
Because the teacher, if she saw me, I was in huge trouble.
And here's the trouble. We tell them not to, and what do? They stick them under the table.
Or
no, even worse. They turn into head bobbers.
They're not slick.
No.
They're not slick.
Yeah, so that's a tool. Your hands are a tool.
Yeah, and Bruce says, and we were good at math, so we want to jump in and save them. Totally get that. Totally get that, right?
Right.
By the way, thanks, Stacen, for sharing this. Hey, my friend Billy Hool asked a question.
What's the next?
He says, do they know how to ask the right questions?
Well,
do kids know how to ask the right
questions?
They
don't, but I'll tell you, I was in a first grade class a couple of years ago, and children were asking amazing questions of each other. Guess where they learned it? The teacher had modeled it. Asking good questions. And so, yeah, there are things that we still need to do, but through facilitation as opposed to lecture or just telling them how, or suggesting a strategy, which, by the way, in our standards, in the revisions to our standards, the definition for strategy is student invented. So if you're getting it out of a book or you're telling them, it's not a strategy.
That's kind of mind-blowing. That's crazy. Okay, I want to pause on that one for a moment. I got to let that one
sink
in for a moment.
Okay.
That the definition of strategy is student invented. I kind of dig that.
I like it too because there's in this training today I had 32 participants, and
that's a big classroom, by the way.
Right.
For a teacher to work with kids individually.
But I had 32 participants, teachers in the room, and 9 different tables. And at every one of their tables, after I made them do a problem using a manipulative or a picture, they all said that there were multiple strategies at their table. And that's adults.
Well, because adults know math and they know how to do this. But to go back to Billy's question of do they know how to ask the right question, I find that kids know how to ask questions when we help them learn and give them space to and freedom to. The kids have a billion questions. It's just we've learned them to shut them up and just listen. So when we allow them and create an environment where they can ask questions, they may not be math flavored, they may not be social studies flavored, they may not be, but they're questions that I can hear, and as a professional, I value it, and then say, and then a scientist would sound really smart because they'd ask the exact same question this way. And so then the kid gets some value in that they were thinking, and that I get to drop in the actual vocabulary that I wanted them to learn and use. But I don't lead with that. Right. The kids lead with the questions.
I think that needs to be flipped upside down too. I think that we used to experience the I do, we do, you do.
I hate that.
I do too. Because I think that needs to flip upside down.
Yes.
I think when I teach CGI,
cognitively guided instruction.
Yes, I've prepared a problem or a set of problems for kids to work on. But then they do it. So it's the you do up front.
Yes.
And then we come together and we discuss. And so that's the we do. And then only in the instances where I think I need to tie a neat little bow on it, or I need to make that vocabulary explicit,
tied.
then I come back in at the end and I do. So it's just flipped on its heel. Not that those pieces don't have parts that play important parts in our lessons, in our units, in our days, but that it's not in the order that we experienced it.
Okay, so this is the advice sometimes I give teachers. Tell me if I'm on track for your math mind.
Okay.
Because I could be just leading them down a bunny trail. A lot of times, and I saw my buddy in here, the guy who gave me this question, so I'm going to be really, if he wants to out himself as the guy who ran into this, he can. He's doing PBL in his math classroom, rocking it out. The kids are having great discussions. He is just over the moon with the great thinking they're doing. And they get to the end, and he's like, all right, they've got to be able to take tests. He gives them the test, and they flat freaking bomb it. And he says, and he was just devastated. He said he had to let 3 days pass before he'd even reach out to me and say, what the heck, Ginger, you said. And my recommendation to him was, well, first of all, value that they were doing math. I said, did you spend any time saying, okay, you're doing real learning and thinking, this is how math happens in the world. Now on our tests, it's going to appear like this.
And I work with several districts that have purchased curriculum and spent good money on it. And then they're trained in CGI and they go, okay, Renee, we really like what we're hearing from you, but... Can
you fit good learning into this box that's really small with no windows?
And so this is what I say, because again, some of that curriculum asks teachers to teach the strategies. And so this is what I say. Okay, I go back to Glenn Wiebe.
Okay.
And I go to Understanding by Design, and I say, begin with the end in mind.
Yep.
And I say, get your little rear end to the back of that unit and look at that assessment, and don't cheat them out of the opportunity to do well if you're required to give it. But come through this other process to get there. Let them experience, let them discover, let them solve, let them teach each other, and then make sure that you've tied it to however it's going to look, so that they're not caught off guard.
Well, and what happens is that people who don't understand that kids have understood math, but I only know math as this, they can't value the real learning, and so it's almost becoming bilingual, is what it is, until finally our math old school switches their minds.
Right.
Billy says, so then we evolve from information that you can't implement to knowledge, to useful information. Yeah, absolutely. That's what this is about. By the way, Billy's not a teacher.
Well, good for you, Billy.
He's just a curious fella. So, in more ways than one, he's very curious.
Well, we need teachers who are curious and want to. Here's another thing I said today. You know, in my opinion, a really good teacher has to model for their students lifelong learning. and they can't know it all. They have to be willing to learn from their kids. And
That's
so,
right. That's
anyway,
right.
I had a great day today, and I have a great group of people that I worked with, and I'm looking forward to this other, but I just know that it's a little harder sell.
If you have, again, I believe that people who are in this right now already have are believers. If you have colleagues who aren't believers and you need some help, this is Renee Smith. Just ask me for her contact information. I'll let you know. Renee works mostly around in this Kansas area, but you do travel out?
I do.
And so the way she lays it out, she's like super freaking fun and professional. So she doesn't use the word frickin'. And
well, on day 3, I might.
and she's got really great examples. Go up to what age?
I primarily work with K6, but obviously I'm hitting 7, 8
Yep,
next week.
absolutely.
Have before. I just don't do quite as much work there. There's a lot of work to do with primary age and elementary grades because, honestly, for a lot of them, math wasn't their thing.
Well,
and so they were readers. And guess what? I can speak to that because I was going to be a children's book author. And then somebody up there had a twisted sense of humor, and every job was a math job. So there you go. Turned into a math specialist. How'd that work out?
I'm so glad you're here and that you came in and talked with me and showed me this
Scooter
horrifying. Oh, the scooter. Pedro has 2 toy trains, one colored red and one colored blue. The speed of the blue train is 4 inches per second faster than twice the speed of the red train. The train starts at the same point. I can't even finish it.
They can't use an equation. They're not going to get to use an equation.
Yeah. Anyway, I understand that we've got some hail coming our way, so we're going to go ahead and close up here and maybe get home into our basements or
At
that
least the
sort of
car
thing.
in the garage. That would be good.
Yeah, I live in the ghetto. I don't have a garage.
Oh, okay.
It's okay. I drive to the state fairgrounds and park under a building.
There
So
you go.
we got plans. We got plans. Hey guys, thanks for joining us. Renee Smith. Appreciate your thoughts with us.